has tried to explain to me at least once before, and
This time.
this time it's going to be amazing.
Yes.
Robert.
So I don't have a formal presentation, and I don't really have a point I'm trying to make with this talk, but I clearly have a burning need for attention, so we're going to have to see how this works out. So homoiconicity, and I'm not sure how many times I'm going to say that, as few as possible, in programming languages is where the code of the language is pretty much one-to-one with the abstract syntax tree that is generated, right? So there's a direct relationship between the code and the compiled output of that code. And this isn't even my idea. Someone mentioned this at a conference, and I thought it was a really interesting idea, and I've been kind of exploring it in my mind since. And the idea of homoiconic deployment is that what gets deployed to production should be the same as what the developer is creating in their environment, right? And so in some cases, we kind of get homoiconic deployment for free with things like Ruby and Python. If we think about delivery on disk, the disk structure represents what we put out in production, but we still feel a little bit dirty about doing something like including maybe our unit tests and our documentation in the thing that goes out to the production server, right? We quite often trim a deployed disk structure. And I think it's kind of interesting that we kind of feel the lack of homoiconicity in our deployments because we put a lot of effort into trying to reconnect the source code, the origin, with what's in production, right? If we think about what we do with compiled artifacts, for example, no one loves the error message, segfault at memory location, right? We actually include debug symbols so we know kind of what line, what source file that came from. It's really interesting when you look at something like JavaScript, for example, that there's a lot of effort going in to try and reconcile the different phases of that language. So you, for example, you have a higher order language that compiles into JavaScript, and you have a source map that allows you to relate the higher level language to the JavaScript. And then when the JavaScript runs in the browser makes a lot of effort to try and reconcile the stacks and frames of the C or C++ engine that's actually running the JavaScript and relating it back to the JavaScript code, right? So we kind of feel instinctively the need to relate the code to the deployable. Now, in some cases, we don't get a choice, right? The languages, if you got C, you're going to deploy an executable. But there's a number of languages now where we do get a choice about how we run things in production. Go and Clojure, for example, can both be run in a kind of not interpreted mode, but where they use the disk structure and they kind of compile into memory. So this isn't about saying that compiling is bad, but saying the idea that compiling to a file artifact and then pushing that through the system is maybe outdated. You can have a structure that is completely consistent through all the path to production, and then for performance, you compile it into memory as a kind of memory-based executable for those reasons. So there is, I think, a difference between the idea of a homoiconic deployment and the idea. So I guess as a developer, I'm coming from a development point of view, and I don't see things like Vagrant or virtual machines, for example, that replicate an environment as being quite the same thing, because I don't think the virtual machine is really what I'm working with when I create an application, right? So I want a minimal environment that this thing runs in, but then I think you want to create a structure that says everything about what it needs to run and do actually within itself, right? It's entirely consistent within itself. It's not pulling anything else in. At most, you want an image that can kick off and make sure that thing keeps running, okay? So that's basically the idea of homoiconicity in deployment. And I'm kind of interested in asking you as a discussion, why can't we do it? Yes?
Because
Developers want to use Max. Is that true? I think, I think it's interesting. if we could get advantage, why do we use Macs? I mean, we use Macs here mostly because IT procurement is terrible, right? And the brilliant thing about Apple is when you say, I want a 13-inch MacBook Pro, no one goes like, well, which model? Sorry, yeah.
What about containerization, such as Docker?
Yeah, I've thought about, what I'm really describing is this unit, this deployable unit that goes out in something like Docker. And I guess I feel like it's not quite the same thing, because also I think about Smalltalk Images, right, which are totally iconic, right? That's like absolutely fine. Like I'm developing my Smalltalk image and I push it into production and then I go, oh, that doesn't work. So I pull the production image back and like restart it and stuff. And a virtualized container doesn't quite feel the same thing to me, and I can't quite put my fingers on why, which is...
I think it's very early days still, but the idea of being able to sort of bundle everything up into this thing and then move that thing through your CD pipeline and all the way to production, and then if it doesn't work, switch it back to the previous thing that's there.
I think there'd be something really exciting about, so for me, like the classic thing is like we have a developer machine which might be Apple or might just be we haven't updated things because we're all running random weird stuff on a client side. Then we have a build machine, right, which is its own weird environment with its own rules, right? And then production's completely different again. And it'd be like a real test, I think, for something like a Docker container is like if there is a problem in the build process and you go like, I understand why that's happened, and I can completely replicate it in this container here. The build system is no longer a mystery to me. It's completely consistent with my dev environment. Sorry, so I skipped you, and you're going to mention Docker. Someone beat you to the punch. Do you want to like put a different angle, spin on Docker?
But I think the point is that you can really, because it is that you can enter the image and then you fill it with it, and then you can connect it again.
Yeah.
Then you can push it to your server, so you can actually kind of do what you said, which I think is really
Yeah. Could be the answer. So I'll take someone right at the back because you guys in front can't see.
What about things like ISV, which is nearly this is like an operating system, a virtual operating system that's literally just running a JVM. So it's actually
Yeah, I mean that sounds brilliant, right?
Like a container.
Yeah.
But it has lots of the characteristics of a virtual machine. Is that?
That is definitely part of the puzzle, but then obviously we're so used to compilable artifacts in something like, Java that we don't think about running it's kind of weird, right? Like we talk about wars and jars, but like how many times have we actually run the war in, like exploded mode because we can't fucking reason about this zip file. We have to see what the layout is, or the first thing that someone does when they got like this jar isn't working, it's like, well, unzip it. Let's see what's inside it, I think there's some odd things, but yeah, it's an interesting idea. Phil.
So one of the things I felt you were getting at with source maps and with Go and Clojure compiling from source on the production environment is that you've got the code there, and I don't think that's something that Docker provides. In my dev environment, I can take any piece of code, run it in isolation in a unit test, and if there's a problem in production, then a fantastic way of diagnosing that would be to be able to have the same level of control of the production code that I've got over the development code. So it feels like there's more to this idea than just having a nicer deployable artifact.
I was wondering if it was too weird to introduce that idea, but I think it is quite tempting to say, like, can I run my unit tests in production, right? It's like, well, this fucking thing isn't working. Let's see what the unit tests still run, But I think it's kind of quite alien, the idea of, like, shipping the whole bundle out to the end because you might want to do exactly that. I think it's quite an alien idea to run the test suite in production. Sorry.
Enough of Ruby or Python people.
I think we still strip out the test directory when we're going to production. It's less alien, I agree. It's more, but the idea that you would just go onto a box and go, I'm going to like py run or whatever, test run, I think is still quite strange. Maybe not so much as I think, but yeah.
What to do with that big thing here is figuring out what problem you're trying to solve, like what you describing like being it doesn't work, it works in development, it doesn't work in production. You talk about
So, so I should expand on this. So I think the problem that I'm trying to fix is the gap between operations and development when we're talking about problems. And, ops people going like, your war's like erroring, it's got this error log. And you go like, I cannot relate to that at all. My life is not about wars and RPMs and images and all this fucking shit. It's like, the app is actually made up of this source code, right? And it works or it doesn't work based on this source code. Because it's literally like I guess my goal is to eliminate works for me, right? Works for me is shit, right? But it's true. It's shit because there's an element of truth to it. Like, it literally does work for me,
Do you want a job where we mainly do interpreted code?
So as someone who's like recovered, let's say, less than 5 applications that you forgot to get push off Google App Engine, it's like, yes. But I think the point is that the interpreted and compiled code thing, I think, is going away, right? Because, like I said, the idea of the big difference between interpreted and compiled code being that there's an artifact produced by compilation is something that I don't think is necessarily as true, right? I mean, there is no reason why you can't take a big, complicated... There's no executable, right, that is bigger than memory, essentially. That's what I believe. No. But, like all applications, realistically, they fit in memory. So, it's what you do in build systems to improve build systems, right? We kind of like build and we get stages, we write stuff to disk. Why bother with all that? Why not compile, write to memory, and then run all the tests in memory? And there's, languages that kind of just go like, why skip that output stage? It's legacy. So I think yes, I may have problems that I fix through interpretation off disk. But even then, in stuff like Python and Ruby, it's quite difficult to restart the system, to make a change on disk and then take effect and have a look at one machine. You need to think about that and restarting server processes to get it to take effect. I mean, some things like Clojure where you can hook in the REPL and change, and you have a semantics of reloading certain elements or swapping out elements. Like in an event-based system, it'd be quite nice to go into your shell or your REPL and apply a tap to an event source so that you can look at the events that are occurring in the system and then run it through your own code to diagnose it, and to be able to take that code, the basis of that code, from the code that you've deployed to disk. That'd be quite a nice system. And I think we're going to see more of those systems. With the lightweight code processing and stuff like that, it seems more likely that you get an event-driven language at some point.
Okay. Thanks very much,
Thank you.
Robert.